Okay, these are the Geometry 7.4 video notes, probably part 1. I don't think I'm going to get it done in a single video. So let's start with this prerequisite skills practice. So if you see right here, this shape is asking us to find angle 1 and angle 2. And so the first thing I know is if I know this top side is parallel and the bottom side is parallel, then I know that these two angles are alternate interior angles. Picture back when we did parallel lines and transversals, that alternate interior angles were congruent. So angle 2 is 39 degrees. Now, the other thing I know, because I know that this side, the left side and the right side are parallel, that means that these two angles, the right angle and then this angle, that's angle 1 and angle 2 combined, they are supplementary because we know consecutive interior angles add up to 180. So if this angle is 90, this other angle has to be 90. And so that means that angle 1 plus angle 2 equals 90. If angle 2 is 39 degrees, then when you subtract 39 degrees, you get that angle 1 equals 51 degrees. Okay, so we're talking about some vocabulary today. So the definition of a rhombus, a parallelogram. So if you already know the figures of parallelogram, you know the opposite sides are parallel. If it's a parallelogram and it has 4 congruent sides, then that means it is a rhombus. So a rhombus is a parallelogram that has 4 congruent sides. All the sides are the equal length. Okay, the rhombus corollary, the whole point of this is you can use it to prove from a quadrilateral. So like you don't already have to know it's a parallelogram, you just know it's a 4-sided figure. So if you have a quadrilateral, it is a rhombus if and only if it has 4 congruent sides. So as long as you know that you have a quadrilateral with 4 congruent sides, then you know it's a rhombus. So now we also have a rectangle. If you know something's a parallelogram already, and if it has 4 right angles, so 4 90-degree angles, then that makes it a rectangle. The rectangle corollary, the point of this one, is that you can start, instead of starting with a parallelogram, you can just know that it's a quadrilateral. So if you have a quadrilateral, a 4-sided figure, even if you don't know it's a parallelogram, if it has 4 right angles, then you can use the rectangle corollary to prove that it is a rectangle. So you use the definition if you already know it's a parallelogram and you're proving it is a rectangle. Use the rectangle corollary if you're starting with not the fact that it's a parallelogram, just that you know it's a quadrilateral, and you can prove it is a rectangle. All right, the definition of a square. A parallelogram is a square if and only if it has 4 congruent sides, so 4 equal sides, and 4 right angles. So the square corollary is the same as the other corollaries. You can use it to prove that a quadrilateral is a square if it is a rhombus, because it has 4 congruent sides, and a rectangle, because it has 4 right angles. So it has 4 congruent sides and 4 right angles. All right. So here's kind of some interesting, like a Venn diagram graphic organizer that's showing us some things. So in the family of parallelograms, you have a rhombus. A rhombus is only a shape with 4 congruent sides. You also have rectangles. They are the parallelograms that have 4 right angles. If you have either one of these, they are also parallelograms, meaning all the facts about parallelograms apply to rhombuses and rectangles. So then, if it is a 4 congruent side and 4 right angle, it's a square. Squares have all the properties and rules of rhombuses and rectangles and parallelograms. All right, this says for any rhombus QRST, decide if the statement is always or sometimes true. Draw a diagram and explain your reasoning. So I don't know that my rhombus is perfect, so I want a parallelogram with 4 equal sides. It's not going to be exact, but good enough, and then just label it QRST. So it says angle Q is congruent to angle S. So it wants to know if this is always true, sometimes true. So this is always true. And if it is a rhombus, that means we know it is also a parallelogram. So because it is a parallelogram, not just a rhombus, it's in the parallelogram family, opposite angles are congruent. That's one of the 5 facts we learned about parallelograms. Okay, it wants us to do it again, so let's draw just a rhombus, so like a parallelogram, except try to make all 4 sides equal, and label it Q, R, S, T. And it wants to know if angle Q is congruent to angle R always or just sometimes. So this is going to be just sometimes. So if it was a square specifically, then remember, a square is a special type of rhombus. If it was a square, then its angles would be right angles. And that is when those angles Q and R would be congruent. So if it was a square, then angle Q would be congruent to angle R. But if it was just an ordinary rhombus, not a square, like if you look at this one right here, these are clearly not congruent. We have an obtuse angle here and an acute angle here. So that's why it's not always true. Okay, using properties of special quadrilaterals, this is example 2. For any rectangle ABCD, decide if the statement is always or sometimes true. Draw a diagram and explain your reasoning. So same as the last time, except we're going to make a rectangle. So remember, rectangles are parallelograms, but with right angles. All right, so I'm just going to draw it the best I can real quick and label it A, B, C, D. So it wants to know if angle A is always congruent to angle B or sometimes. So this is going to be always. And our reason is rectangles have 4 right angles. And obviously, right angles are congruent to each other. Okay, let's draw another one and check this out. All right, so AB is equal to CD, meaning that their lengths are the same. So let's label this A, B, C, D. So this is side AB and this is side CD. So that would be always, because a rectangle is a parallelogram. And on a parallelogram, we know that opposite sides are congruent. Okay, let's look at example 3. On example 3, it says classify the special quadrilateral. That just means tell if it is a parallelogram, a rhombus, a rectangle, or if it is a square. So one of those. So it's based on what we know. So currently on this shape, obviously we know it's a quadrilateral. We know that all 4 sides are congruent. So that is going to be a rhombus. And here's why. I'm just going to show you back on our properties here. The definition of a rhombus, we can actually do the rhombus corollary, because if you look at that image, we did not know that the sides were parallel. So we don't know that it's a parallelogram. We just know it's a quadrilateral. And so the rhombus corollary says a quadrilateral is a rhombus if it has 4 congruent sides. So because I did not know this was already a parallelogram, I've got to use the corollary. So I'm going to say the rhombus corollary. All right. So if we look at this one, we do know that this is a parallelogram. So right here you have 2 pairs of opposite sides. Both pairs of opposite sides are parallel. So you know it's a parallelogram. Now, you know that this side has 1 congruent mark. And if it's a parallelogram, opposite sides are congruent. So this side should also have 1 congruent mark. Now you know the right side has 1 congruent mark. And since you know it is a parallelogram, that means the opposite side, the left one, should also have the same congruent marking. So that means all 4 sides are congruent. And so it is technically a rhombus, to be the most specific. All right, so it is a parallelogram because the opposite sides are parallel. And since opposite sides are congruent, and it already had those congruent markings, all four sides are equal. Well, or congruent. And so we can use the definition of a rhombus. Okay, so what we have here, we don't know it's a parallelogram. We do know all four sides are congruent. So that's all we know right there. Now, so from there, if we know that both pairs of opposite sides are congruent, that would let me state that it is a parallelogram. So because both pairs of opposite sides are congruent, that gives me the right to say, hey, this is a parallelogram. All right. Now, since we know that opposite angles are congruent in a parallelogram, you know that that's 90. And you also know that consecutive angles are supplementary. And so that means these two angles add up to 180. So this must be 90. And it also means these two angles add up to 180. So this must be 90. All right, let's jot that down real quick. So we know it's a parallelogram. And because of opposite angles and consecutive angles, I guess congruent, opposite angles and consecutive angles being supplementary, I'm going to abbreviate that, we can show all four angles equal 90 degrees. So now if we've shown that it equals 90 degrees in all four angles and that all four sides are congruent, that is enough to say that it is a square. All right, just real quick, I wanted to show you this. This is the foldable that I had printed for you. So I'm sure Miss Davis has a different method of doing this, but I went ahead and just added everything onto it. So what you could do is you could go through and just highlight like opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. And you could do that on each of the different shapes. I included the names of the theorems or the definitions or the corollaries because I wasn't sure if you would need this to actually prove them. So that's why I included the names. But the basic facts of everything that we talked about here or will talk about are on here. And so then you can show that a rectangle has four right angles. And it is a rectangle if its diagonals are congruent. You could also draw in on those shapes to kind of demonstrate what each thing says. So on a rhombus, we learned that it has four congruent sides. We haven't learned this yet, but the diagonals have to be perpendicular, meaning they intersect at a right angle. And the diagonals bisect opposite angles, which we'll expand on that in a future video. And then on a square, let's see, it has four congruent sides and four right angles. But I put the names of everything. And on the back side, I put the converse and theorems and things that we learned about if you are proving a shape as a parallelogram. That's what I would use.